All right, well, welcome to the last day of Newcraft before we go on, or before this exam. Wednesday will be a review day. It's kind of a warm up to the review tonight. And what we're going to talk about today is changing the basics. I think it's number 7. Now, in principle, I could just drop the mic and walk out of here because in principle, you all know how to do this, right? I've asked you some questions about it, and there's really nothing a whole lot new. However, I'm going to go through this carefully because I want to make sure that you all kind of understand what these coordinate systems are. I'm going to do a change of basis really from scratch, like the old homemade whisk from scratch. And from that, I'm going to show you an algorithm, just like finding the inverse, that you can do it kind of quick. So hopefully this will be useful to you. All right, so let me start just via example and do a change of basis, right? So let's suppose that I'm gonna have two bases of R2. I'm gonna have B is 1, 3 and 1, 4. We'll have another basis 2, 5, 3, 7. Now, let me ask you a couple questions before I get. So, what do these coordinates mean? So, what does this vector A, B, and B coordinates mean? What does this actually mean when you see this notation? Yes.
Is it the vector AB with reference to the B basis or in terms of the B basis?
You're right. I think you got it. But I mean, how would I, if I'm a practical fellow and I want to write out what this is, what do I do? Yes.
So it'd be A times 1, 3 and B times plus B times 10.
That's exactly what this means, right? Everybody comfortable with that? So this is just a notation. So for example, 1, 0 in B coordinates is just 1, 3. 0, 1 in B coordinates is just 6. Right, okay? Okay, here's a question too, just for fun. Why did I pick the numbers that I did? Does anybody see a pattern? Now keep in mind, when you try to answer this question, I'm a lazy man.
You take numbers.
Okay, and why is it?
Just 2 by 2.
Right, but there's something even sexier than just 2 by 2 going on here.
Oh. Sure, that's right.
That's right. If I wanted to have a matrix that changed B coordinates to standard coordinates, it's just this matrix that I make, right? Everybody agree with that? What's the determinant of this? 1, 1. What about this one? 2. 14 minus 15, -1. And okay, it's -1, but even I can figure that out, right? That means that everything that I do should probably turn out to be in. See, lazy man. If I had gotten determinant 2 and determinant 3, I might have some fractions with some 3s, 2s, and 6s, perhaps in the bottom, right? So that's just kind of an interesting observation. You know, doesn't really bear that much on what we're going to do here as a process. So, what if I asked you to I'm going to ask you to do this. I want to find the matrix that changes B coordinates to C coordinates. And I want to emphasize to you that once I get this gobbledygook matrix, I can check it. And again, that's a great thing about math, and I'll show you how we check it. Well, one way to do it is One matrix, what's the matrix that goes from B coordinates to standard?
Yes. 1, 1, 2, 1, 1, 3.
Okay. You just put in the columns of B, right? And this is easy to check, right? Because and that's the standard coordinates of the first vector in the V basis, right? So that's kind of a good gut check. Everybody okay with that? Okay, well, this should be the same crap, right? I mean, it's 2, 5, 3, 7, right? But really, actually, what I want to do is I actually want standard. See, what I'm trying to do is change B to C, right? So maybe if I change B to standard and then standard to C, right? It's just like a little one-stop train, right? B to standard, then standard to C. That'll do my whole job for me. Only this train's going the wrong direction. I want to change standard to C, not C to standard. Oh dear, oh dear. What will I do?
Inverse.
There you go. The inverse, this matrix here, is 2, 5, 3, 7, change C to standard. So this should be 2, 5, 3, 7 inverse. Right? And I could work out the inverse, but let me just say that 2, 5, 3, 7 inverse should be, let's see, that becomes -1, should be, it's a 7. I do that right? It looks like I did that right. Right, Richard? So now, that's controlled by this matrix here, -7, 3, 5, -2. Now, the question is, how do I get from B coordinates to C coordinates? What should I do? So I've got a tool here. This tool takes standard to C. I've got another tool. This takes B to standard. What do I do? Yeah,
I think you just make B and C negative when you put D and A and then make B and C negative. When you do the inverse, you know what you do.
well, so
Well, then you multiply
so
by
think
two.
about it this way. What I want to do is I want to I want to take input B and output C coordinates, right? That's what I want to do. And what does this matrix do? It takes B to standard. So I can do this matrix here. Now, when I've gone this far, I've changed this to standard, not a match yet, just a standard, right? How do I kick it on down the road? Do the other matrix, do this one, that now turns standard into C, right? Order is very important. So let's see what happens. This is, whatever that was, -7, 3, 5 -2, I guess. So when you have your B coordinates here, first step to standard, second step to C. Everybody okay with it? And we can get this all together by multiplying these two. So this is -7 plus 9 is 2, minus 7 plus 12 is 5. 5 minus 6 is -1, and 5 minus 8 is -3. That matrix should take the standard. So let me write the answer down here. I'm going to come up with this another way. Okay, I'm gonna do this another way, but first, before I do this thing another way, let's make sure that this is freaking right, right? I don't want to do the problem wrong 3 times in a row, right? So let's at least check. So if I'm right, what should happen is this matrix here, 2, 5, -1, -3. When you input, say, X, Y in B coordinates, you should get the correct thing in C coordinates. And what does this matrix do? It goes 2X plus 5Y, and it goes minus X minus 3Y. Everybody okay with it? Okay, well, there you go. How do I check if this is actually working for me? Right, let's just check the coordinates, right? Let's check these both. Let's see if they match in standard. And if they match in standard, I'm good. Okay, so what is this here? Well, my input here is what is X, Y, and B? Well, this is going to be, so X, Y, and B is X times first coordinate B, which is 1, 3, plus Y times second coordinate, or the second B vector is this. So I get and this is 3X. Right. Keeping up here. So this output here is 2X plus 5Y and minus X minus 3Y. See, what is its output? This is the thing to focus on. Let me be careful. This is 2X plus 5Y in C coordinates. That should be, what should I put right here? So what does this mean in C coordinates? The first coordinate is 2X plus 5Y. So that's 2X plus 5Y times what? The first vector, right? So that's going to be, so that's going to be 2X plus 5Y times this first vector here, which is 2, 5. And then this is minus X minus 3Y times the second vector, which is 5, no, I'm sorry, 3, 7. Well, piece of bone. So what this matrix does in C coordinates, well, It's two x plus five times the first c coordinate, this times the second c coordinate, so this, or c vector, so this becomes. 4x plus 10y. That's the top coordinate here, right? And then what, minus 3x minus 9y? Everybody agree with that so far? Let's check the bottom coordinate. That should be 10x plus 25y. And then 7 times this is minus 7x. Minus 21. So what does this come up to? This is what? X plus y. And this is 3x plus 4y. Do I agree with them? And so what this matrix does is it takes this and it takes that vector there and turns it into the appropriate C coordinate. So we got to check there. Am I okay with that? Okay, so let me do this another way. So now we know that this is the right matrix. It does what I want. It takes X, Y, and B coordinates and it turns it properly into that. Right. Let me do this even more from scratch. So what we want is we want the matrix that takes X, Y, and B coordinates to C coordinates, right? So let me kind of set this up. We know that our matrix M is this. So we want to find A, B, C, D to make it work. Right? And this is really from scratch. But again, it's linear algebra. All you have to do is set it up and you will have linear. Okay, so what do we got to make happen? Well, we have to find A, B, C, D that takes X, Y, and B. Well, okay, what is this matrix going to do? It's going to go to AX plus BY and CX plus DY and C coordinates. Right, we want to change my B coordinates to C coordinates, right? And we need to find A, B, and C, D to make this work. So, how do we do this? And somehow, I guess we've got to use the basis B here, right? So we're trying to take input B coordinates, output C coordinates properly. So, anybody got anything that will help me along? Well, let's write this out sort of in standard to make the thing work. What does X, Y really mean? Well, again, X, Y, and B coordinates is X times 1, 3 plus Y times 1, 4, which is X plus Y times 3X plus 4Y. correct? And if I look at AX plus BY, or if I look at AX plus BY, CX plus DY in C coordinates, this is AX plus BY, and the C coordinate gives me 2, 5. Plus CX plus DY. 3, 7, I guess. Which is let's see, that's going to be 2AX plus 2BY. Plus 3CX plus 3DY. And on the bottom, I'm going to get 5AX plus 5BY plus 7CX plus 7BY. Everybody, okay, with that? Everybody see what I did? And so equating the coefficients. What I need here is to compare these two, and I get the following system of equations. 2A plus 3C one. I'm gonna write these down. 3 and 2B. That's 3D. 1 and 5B. 7B. Okay, can somebody tell me where these came from? That is correct, comparing the coefficients. The X4 coefficient 2A plus 3C, you know, compare the coefficient here is 1. 2B to 3D, compare 1 also. 5A 7C compared to 3. And 5B to 7D compared to 4. Now, this is two systems of independent equations. This is two equations of two unknowns, A and C. And then an independent set over here will be B and D. And these both can be worked out fairly easily. In fact, the strategy for working them out is the same. I would multiply for the first one, I would multiply this by 5 and this by -2. For the first one, I'd get 10A 15C is 5. And minus 10A minus 14C is equal to -2, or I'm sorry, -6. Multiplying the second by -2. This gives me C equals -1, and if C is -1, then that's going to be A is equal to 2. So here's A and C. Get 2 and minus 1, right? You get the same thing going on with the other ones. Again, I'll multiply the first equation over there on the right by 5. I get 10B plus 15B is equal to 5 again. Yeah. And minus 10B minus 14B is equal to -8. Right. Subtracting these off, I get D that is, -3. And if D is -3, that's going to be, B is 5. So, there's your 5 -3, when we cover the matrix. Everybody okay with that? But now, lucky you, let me give you a theorem. Here's the big shortcut, right? But does everybody understand how to compare it, how to check it, and what these bases actually mean, C coordinates, B coordinates? Any questions on that?
What does it mean, like, can you show that matrix changing B to C?
Yeah. So we can do that. Here, let me do this another way. 2, 5 -1 minus. What does this matrix do, right? Well, it takes 1, 0 in B coordinates and turns it into, what does it turn into? 2, -1 in C coordinates. You okay with that? So how do we check it? Right? Well, what this matrix is doing, this is a linear transformation, it's a matrix. It is taking this B coordinate 1, 0 and turning it into C coordinates. So if this matrix is done what I predicted it should do, the B coordinate, the B vector 1, 0 should be the C vector 2 - 1, right? Well, let's look at 2 for C vector, 2, 5 plus -1 times 5/3/7. This is what 2 - 1 means in C coordinates. Everybody, you guys okay with that? Are you okay with that? This is what 2, 1 means? Let's see what this is in standard. What's my top coordinate in standard?
1.
It should be 4 - 3, which is 1, I agree. What should my second coordinate be? It should be 10 - 7 is 3. I agree. Notice this output matrix, or this output vector is this in standard coordinates, right? Because we've done the computation, which is exactly the first B vector, right? This is 1, 0 in B coordinates. So this did exactly what I wanted it to. It changed, and remember, 1, 0 in B coordinates, what that means is 1 times this plus 0 times this. Right? 3, 2 in B coordinates is 3 times this plus 2 times this. Does that clear it up for you? And you can do this more generally. I mean, try 0, 1, and you will get whatever you get. You get the second column, 5 - 3. When you do 5 times this plus -3 times this, you should get the second B coordinate, or the second B one, which is. Does that clear it up a bit? Any questions? Okay, so let me give you a theorem, and then I will implement this a couple of times. Let B equal B1, B2, these are in vectors, Bn, and these are vectors too. The bases for vector space P over R. You can't do this one generally, of course, if these are both bases, they better have the same number of elements in it, they both better have the elements in it. Which they do, then. There is. A unique. Matrix. And I'm gonna follow your book's notation on this. Uh, so. If you have two bases. And you want to change the B coordinates to the C coordinates, right? And these don't even have to be in Rn, but, so here you have your list of X and C coordinates. Now, this is in Rn because this is a list of numbers. It's just the coordinates in C. You can change the B coordinates to C coordinates just by multiplying by this unique matrix. This notation means B coordinates change to C coordinates, right? And the matrix is built this way. I'll tell you exactly how to build the matrix. For P. Is B1. C coordinates. B2. And C coordinates. B, in So the way you build this invariant matrix, and by the way, if these are two bases, this matrix P will always be invertible. It'll always be invertible. What you do is you make the columns just by changing each of these vectors B1, B2, Bn, change them to C coordinates, right? Just change the columns to C coordinates, fill in the matrix with columns, and that's what you get. Now, at this point, you might think, well, that doesn't really help because how do I change the columns to C coordinates? Well, I'll show you. Uh, Left side of augmented matrix. Uh, Two. So you want to go from B coordinates to C coordinates, right? Put your C coordinates on the left, B coordinates on the right. Both of these matrices, since they consist of bases, are invertible. So you can reduce this one to the n by n identity matrix. When you do that, do the same thing to the other side, and when you're done, this thing right here will become the matrix that you see. Right? So let's do this on an example that we know already, and then perhaps one that we don't. And notice this is very much like the algorithm that we have for finding the inverse. It's in fact, it essentially is that. It's just augmented one step. So example again. C. Right. Page B voice. Time change. Well, here's the procedure that we can go through now. This might be short. Let's see, I'm going to C, so it's 2537. Now, I want to reduce the C side to be identical. Right? The first thing I'm gonna do is because I'm a lazy man once again, and I don't want to deal with fractions, I'm gonna multiply the top row by -2 and add it to the bottom. So my next step, I want 2, 3, 1, 1. Multiply by -2 and add to the bottom, I am going to get 1, 1, 1, 2. Okay, so far. Now I'm gonna use this one to take the 2 out. 1, 1, 1, 2. That's going to be 0, 1. Right. It comes minus 2 and add. Now I'm gonna multiply by -1 and kill this. Multiply this by -1 to kill this. And multiply this by -1, so it's gonna be from 2 and 5. And now we need this to be the identity, so I just need to flip these rows. So the matrix M is 2, 5, -1, minus, which is what we got before, I believe. Right? Easy peasy. Right, the algorithm works nicely. Yes,
On the middle bowl, on the right, it says it's the identity matrix, and then it has B, and it's going from C to B. But
oh, I'm sorry, you're absolutely right. I freaked out there. It should be, thank you. It should be B, absolutely. Let's do one with a little bit more meat on it. Example. Let's let B be 1, 0, -1. 1, 1, 1. 1, 1, 0. And C to be 2, 0, 1. Hope it's mine. -1, 1, 1, and 0, 1. Find the matrix that changes B forms to C forms. By the way, you're going to have to trust me that these are basics, but let me ask you this. I'm not gonna bother to check at this point, but it will be revealed to me whether these are basics or not down the road. Somebody tell me why?
Yeah, prohibitions.
That's right. For example, if C is not a basis, then there's no way I will ever be able to road reduce the identity matrix, and I will catch my mistake along the way, and I'll run into similar problems with D as well. Right, okay with me? So let's just. It's up here. Let's put in C, which is what, 201. Minus 1.1, yes. 012. And the B side was 101. Sorry, minus 111. And 110. Okay, so what I gotta do is I gotta set about to reducing this, the identity. So I'm gonna use this 1 in the bottom to take out that 2. So it's gonna be 0, 1, 1. I'm gonna leave this for a little. 0, 1, 1. And let's see, multiply by -2 and add. It's 0. Multiply by -2 and add, I get -3. Multiply by -2 and add, I get -4. I gotta do it here too. Get 1. Multiply by -2 and add, -1, -2 and add, -1. Right, okay. And I'm gonna use this to take out this. So I'm gonna multiply this by 3 and add it to the top. So I'm gonna get 1, 1, 2. Minus 1, 1, 0. 0, 1, 1. And 0, 1, 1. Apparently. And multiply this by 3 and add. 0, 0, minus 1. 1, 2, 2. I've made a total mess out of this, so I'm gonna switch some rows up. I'm gonna put the bottom on the top. I'm gonna keep this one in the middle. And I'm gonna flip the sign. Put it on the bottom. -1, -2,
In the first step, we did -1 times -2 plus 1. That should be a 3. The full column.
This step right here.
No, yeah, that first step there, when you did -1. Cause like to cancel that 2, you did 1 times -2 to get 0. And then on the fourth column, you did -1 times -2, which should be 2 plus 1. You have it a 1, not 3.
Okay, so are you talking about this step, first step?
Yes.
Okay, so. 1, 2, times -2 and add, times -2 and add, -3 times -2 and add, -4.
Yeah.
Where's the mistake?
The next one.
Oh, from here to here?
No, the fourth column.
The fourth
On the,
column.
on
first
the
step.
right side.
On the
Oh,
right, side,
over here,
yeah,
times -2, and add should be a 3, that is correct. And I guess this is times negative. See what was this? Times,
that should
negative.
be a negative.
what is it? Times negative two and add. Should be a 3 here. Okay, let's try this again. So let's times negative two and add, negative two and add, negative two and add, negative two and add, that's 3. Negative two and add is -1, and times negative two and add is 1. These are changed. And then what did I do? Times 3 and add. So that's going to be 3, 2, 4, isn't it? Is everybody with me now? Let's try, that's right. And then I just turn stuff around, so that should be right there, that should be right there. This should change everything, so this should be now, -3, -2, -4. Not gonna check. Yes, yes. Everybody okay? All right. So let's use this 1 to take these 2 out above it. 0, 0, 1, -3, -2, -4. And that doesn't appear to be right. Times -1 and add. 0, 1, 0. Times -1 and add is 3, 3, 5. And times -2 and add. That's going to be times -2 and add, that's going to be 6 -1 is 5. That's going to be 4 and 1 is 5. That's going to be 16. And finally, I guess what I gotta do is -1 and add 0, 0, 1. That's 3, -2, -4. 0, 1, 0, 3, 3, 5. And then it should be times -1 and add. So it should be 2, 2, 11. And it's not. So this is correct. This is correct. Something went wrong here. We'll go back and see if you can find it. The actual answer is this, and I know it's the answer because I checked it. I got 2, 2, 3, 3, 3, 5, -3, -2, -4. This should be the actual, yes. Let's see what. Oh, this should be an 8, shouldn't it? That's right. That's not times 4, that's times, so this should be not a 16, but an 8. And then when I add the -5, it should be 3. There we go. Thank you. So there it is. The reason I knew that the last one was right is because I checked it before. Of course, I didn't check myself in the middle, but I checked it at the end. Check it, make sure that this matrix is right. You should change the B forward to C forward. Any questions? All right, well, I will see you all on Wednesday. Right, so I'm gonna give you guys a quiz for Tuesday, and we do Tuesday, probably 8 o'clock. It's kind of the last thing. Your next quiz will be due Tuesday, there won't be one Friday.